Summer 23, paper 1-1. Let's look at question number 1. Which description is of a scalar quantity? Again, it's very basic. I don't even need to look at the options for this one. It has a magnitude and a unit, but no direction, right? Every quantity is going to have magnitude and unit, but only a vector is going to have direction, right? So it has magnitude and unit, so it's option D here. Let's have a look at the next one. All right, a question on kinematics graphs. So the diagram shows a distance time graph for a car traveling in a straight line. In which region is the car decelerating? All right. Again, let's go according to the tips we know for tackling kinematics graphs. This is a distance time graph, right? So what do we know about this graph? We know that the gradient is speed. Now, if you're talking about deceleration, we know deceleration of any kind means a decrease in speed. So we're looking for a region where speed is decreasing. That's deceleration. And on a graph, this means that this is a part where the gradient is decreasing. All right? So if we look at this part, this is where the curve is getting steeper. You guys might recall this as a shape where the gradient is increasing. B is a straight line, and there is a constant gradient here. In C, the graph is flattening out, so this is actually the part where the gradient is decreasing. And D is the part where the gradient is 0, so the speed is 0. So this means basically that the object, the car, is at rest. All right? So again, I hope nobody now has problems with how to tackle questions related to kinematics graphs, as long as you follow these tips. And the tips are basically this, that first you talk about the type of graph you have, then you talk about what the gradient or the area of this graph represents, and then you make your conclusions. 3, a wooden block is pushed across a table at constant speed. Again, this says constant speed. In questions related to forces or in questions related to work energy, this means something very precise. If the speed is constant, in the language of kinematics, this means acceleration is 0. And according to Newton's second law, this means that the resultant force is 0. So on this diagram, you can see a pushing force here, right? If this were in fact the only force applied on this wooden block, it would accelerate. But if it's going at a constant speed, this means that there must be a frictional force which is actually equal in magnitude to the pushing force. That's the only way the resultant force could be 0, if the forward force equals the backward force, right? So both of these must be equal. So the pushing force should equal friction. Now that we have established some of this stuff, let's look at the options. This statement is correct. The frictional force increases as the block moves at constant speed. This is wrong. The frictional force, if this were to increase, the block would decelerate. That's not what is happening here, right? If the frictional force increases, so then the backward force would be greater and it would slow down. It would decelerate. The frictional force is equal and opposite to the pushing force. This is correct according to the reasoning we just discussed. Frictional force is not greater than the pushing force either, for a reason very similar to what was in A. And the frictional force is not less than the pushing force, because if the pushing force was more than the friction, there would be acceleration, not constant speed. Question number 4, a car begins to move, it speeds up. Again, you have this word, constant speed. What happens to the acceleration? What happens to the velocity of the car? Again, this question is also one which has not been asked for the first time in this paper. It has been asked, I guess, at least one time before. So what happens to the acceleration? What happens to the velocity of the car? Now there's a very easy way to answer this question. If it was speeding up, this means there is some acceleration, right? So it's sped up, So it was accelerating and then it reached a constant speed, which means it's not accelerating anymore. So the acceleration is definitely changing. So it can't be C, it can't be D. And if its speed was changing when it was speeding up and then it went to a constant speed, so obviously the velocity also changes. Because acceleration by definition is the rate of change of velocity. So the answer to this one is A. Let's go forward. Alright. The diagram shows how the length of a spring changes when a load of 10 newtons is suspended from it. The 10 Newton load is replaced by a 20 Newton load. What is the new length of the spring? Alright, so what we have here is we know the original length, basically L naught of the spring. Upon application of a 10 Newton load, we also see the new length. Remember that force is proportional to the extension, not to the length. Alright, the equation is F is proportional to X, not F is proportional to L. So first from this value, from these values given, you need to calculate the extension. So it went from 5 to 8 on application of 10. So this means it caused a extension of 3 centimeters. So load, extension. Both of these are directly proportional. So 10 Newton causes an extension of 3 centimeters. And now we have a 20 Newton load. And we need to find the new length. Again, there is no direct way of doing this. First, you'll have to find the extension. You can choose to cross multiply, or you can also just choose to see that if the load doubles, because of the direct proportion, the extension will also double. So the new extension would be 6. Now, don't be quick to check off 6 here, because that's just the extension. It's asking for the new length. So it's the old length 5 plus the extension 6, which makes it 11. Easy. Question number 6, a slightly tricky question in my opinion. A force F causes a moment about point O on an L-shaped bar. The force F acts at point P. So this is where this force acts. And this is basically the pivot, because we are talking about the moment about O. What is the moment of F about O? Alright. So remember that the formula for moment is force times not any distance but the perpendicular distance. So this is how the force is applied at this point. Now we need to see what is the perpendicular distance of the line of action of this force from the pivot. Now, what I really need to do in any case that I need to calculate moment is, if I see this is how the force is acting, all I need to do is from the pivot, I need to select the shortest distance. So from the pivot, the shortest distance to the force, right? Why am I saying shortest? Because you guys know from math and trigonometry that the perpendicular distance is always the shortest distance. So in this case, this is your pivot. This is that entire force. Now you could make a line like this, or this, or this, or this. But ask yourself, what would be the shortest distance? That would be exactly this one. And if you look at this, that's exactly also equal to d4. So in this case, the distance would be d4, force would be F, leading to the moment Fd4. So question number 7, I guess this also I asked in a recent test to some school students and they found this pretty difficult. Let's see what this question is asking. A uniform meter rule of weight W is pivoted at the 25 cm mark and held horizontal by a force F applied upwards at the 100 cm mark. The rule is supported by a vertical force P acting at the pivot. What is the magnitude of P? What makes this question difficult for the first reason is that there are no values associated with the forces. Everything is symbolic. So they've given you an upward force P, an upward force F, and a downward force W, and you are supposed to know P. Now the first thing that you should identify here is that if you just look at the forces because this is horizontal, so basically it's an equilibrium, you can say that the upward force, the total upward force equals the total downward force. So one thing you can directly say just from looking at this is you can say P plus F, both being upward forces, equals W. But now the problem is that you don't know F, you don't know W, and you are expected to find the answer for P just in terms of W, right? So let's see how this is going to go. We also know basically in doing this thing that we're doing, we are using the two conditions for equilibrium. One that we used here is that the resultant force is 0. The other one you guys know is that the resultant moment must also be 0. If I look about the pivot here, so obviously the force P would not create a moment because it passes through the pivot, right? And I can see that there are these two forces which would produce a moment. W, which produces a clockwise moment, and F, which produces an anti-clockwise moment, right? So this is 25. This is at the 50th mark, so this distance is 25. Again, this is one of those cases where you only have two forces creating moments, so it's obvious that one must be creating a clockwise moment, the other one must be creating the anti-clockwise moment. So 25 to 50, this distance is 25. So I'll write this as 25W should equal the moment due to F. So from 25 to 100, all of this distance is 75 equals 75F, right? Now, using this, what I can do is I needed P only in terms of W. So using this equation, I can basically figure out a substitution for F. If I make F the subject here, I can have F just in terms of W. So let's do that. So F is going to be 25 over 75W, which is basically 1 by 3 W, right? So P, if I look at this here, this is going to be W minus F, which is basically minus W by 3, right? So 1 minus 1 by 3. So basically that's going to be 2 by 3W. So the answer is going to be C. Question number 8. Again, this question is also, it's not the first time this has been asked. The diagram shows a stationary fairground, right, with 4 chairs of equal mass. Which chair has the most GPE? So if masses are equal, that also means weights are equal. So the greatest GPE is basically going to be because of H right here. So the greatest height is what we're looking for, which is obviously A. Hydroelectric and tidal power stations generate electrical energy. Do these use renewable sources of energy? And the answer to both of these is yes, right? Hydroelectric is also renewable because that's basically the energy in which we harness the weight of the water and we have it hit from a height which turns the turbine. And tidal is because of the tides of water. So both of these are renewable, right? So they will not run out. Question number 10, which energy source is correctly described? So biofuels renewable, yes. Availability at all times, no. Availability is a big issue with biofuels because it's not readily available. Nuclear renewable, no. Nuclear is not renewable. It has many advantages, but renewability is not one of them. Solar radiation renewable, no. Wrong. Right? And wind is renewable, no. And availability, so obviously if it's not renewable, so I don't even need to go on to the next one. So what's the problem? What did I do incorrectly here? Solar is obviously not renewable. Solar is obviously renewable, so yeah, C and D are wrong. Nuclear is also not renewable, right? Also in the context of other options, biofuel seems the most reasonable. And availability is, at least it's available. What I was thinking of is how effective, how efficient that is. Biofuels are readily available, right? For example, if you harness something like cow's dung or something like that, that is pretty readily available, and it's also renewable, but the problem is it's not very reliable as an energy source because it doesn't give a lot of energy to use. So biofuels is available, right? My bad, it is available. 11, a small motor has a power rating of 10 watts and is switched on for 5 minutes. What is the electrical energy input to the motor in this time? So you have power, you have time, which is in minutes, so you need to convert this to seconds. So it's 10 as the power. I'm using this equation basically. Energy equals power times time. So 10 is the power and 5, and to convert to seconds, this is times 60. So 300 times 10 is 3000 joules. 12, two liquids X and Y are poured into beakers of different sizes. Liquid X has a density of 1000 kg per meter cube. Liquid Y has a density of 900 kg per meter cube. On the base of which beaker is the pressure the greatest? So for the greatest pressure, I would also obviously need the greatest height, so I'm not going to look at these. So it's C versus D. So what is denser? X is denser. So it's going to be the one with the greatest pressure. So I've used this equation, right? For the greatest pressure at the base, density must be the greatest and the depth must also be the greatest. A swimmer is at the bottom of a pool. Density of water is given. Small g is given. Which expression gives the pressure exerted on the swimmer due to the water? So due to the water means you just have to use rho g h. You don't have to add the atmospheric pressure. So rho g h, rho is 1000 and h is 5, g is 9.8. Very straightforward. B is the answer to this one. Some gas is trapped in a large syringe. Atmospheric pressure is 100 kilopascals. Gas pressure is 200 kilopascals above atmospheric pressure. And the piston moves outwards and the volume of the trapped gas doubles. Temperature remains constant. What is the new gas pressure? Alright, so here you also have the atmospheric pressure and you also have the gas pressure, right? So atmospheric pressure here is 100 kilopascals, which is pressing down on this syringe. And the gas pressure is 200 kilopascals above atmospheric pressure, right? So this means that the actual pressure of the gas, 200 plus the 100 from the atmospheric pressure. So pressure is really 300 kilopascals. And let's say I'm talking about this in terms of the equation P1 V1 equals to P2 V2. As you guys might have also recognized from the layout of this question. So I'm going to call this P1, right? Piston moves outwards and the volume of the trapped gas doubles. So if volume doubles, because of the inverse proportionality, pressure is going to half. So half of 300 is going to be directly 150 kilopascals, right? That's the idea which was at use here. So up till now, we have seen some really tricky questions. For example, this one was also where you had to think about this a little bit. It's 200 above the atmospheric pressure, so 200 plus 100. All right, 15. A graph of temperature versus time is shown for a material being heated from its solid state. Which row describes what is happening at X, Y, and Z? Obviously, the horizontal regions must be state changes because the temperature is constant. If you look at this, obviously either of these could be melting or boiling because this is being heated up, right? But could this be boiling? If this boils, then it becomes a gas, and after that there are no more states of matter after gas. So this must be melting, this must be boiling. So X must be melting, so yeah, it's just option D here. Right? Y is where the liquid is heating up. So here the solid is heating up, then it melts, then it becomes all of liquid, then the liquid heats up, then this boils and becomes all of gas. 16. A student on a camping expedition cools a sealed bottle of water which is at the same temperature as the surrounding air. So cools a sealed bottle of water, alright. Which method cools the water at the greatest rate? So how would you cool the water at the greatest rate? Wrap the bottle in aluminum foil and place it in a shady place. So if you wrap the bottle in aluminum foil, so you know aluminum is basically, what do you call it? It's shiny, right? So aluminum, what it's going to do is it's going to make it, it would basically reflect the outgoing radiation back inwards. So it's not going to cool down, right? Because they have the same temperature. The water is at the same temperature as the air. So if you wrap it in foil, the outgoing radiation would be reflected back inwards, right? So this is not something we would really like to do. B, wrap the bottle in dry white paper and put it in a sunny place. Again, sunny is not what we're going for because that would heat up the water. Wrap the bottle in foam and put it in a breeze. Again, foam is also not a good idea because if you think about foam, it has these small air pockets. So it's going to prevent the water from losing heat, right? So this is also not what we're looking for. By default, D must be correct, which is wrapping the bottle in wet paper and putting it in a breeze. So basically the wet paper is going to absorb heat from this sealed bottle of water. So the water is going to lose heat, and basically putting it in a breeze, this is giving you, the examiner is giving you the hint that he's trying to talk about evaporation here. If you put the wet paper in a breeze, so evaporation would be faster, and we know that evaporation produces a cooling effect. Hence it's going to cool down that sealed bottle of water, right? So that is what the idea was here. Again, definitely not an easy MCQ. You have to think about this. 17, a student suggests the 3 factors that affect the rate of emission of thermal energy by radiation from a hot object. These are surface temperature, surface area, and the surface color of the object. Again, look at this. It's asking for the rate of emission, right? So what factors affect the rate of emission? So for the rate of emission, the idea is that the surface temperature obviously does affect how fast radiation happens. The greater the temperature, the greater the rate of radiation. Area as well, the greater the area, the greater the rate of emission. And the color or the texture also affects how fast radiation will happen, right? Dull black is a good emitter, and shiny white is a good reflector, right? A poor emitter basically. So yeah, all of these affect the rate of emission. So the answer is 1, 2, and 3. All of these are correct. 19, a plane mirror on a vertical wall forms an image of an object placed in front of it. Which characteristics describe the image? So real, obviously it's not real, it's virtual, and it's upright, it's not inverted, right? When you look at the image, you see your head at the top and not at the bottom, so it's upright. The diagrams show light traveling in air incident on the surface of a glass block. Some light is reflected, some is refracted. Which diagram shows the reflection and refraction of light? So reflection is shown properly not in A, because if this is the boundary, the light must go like this. So it's definitely not A. And then it could be either of B, C, and D, because reflection is shown correctly here, right? Now about the refraction, it can't be like this. This obviously is wrong. This looks like reflection, but in another dimension of sort. So this is wrong. So now between C and D, because light is moving from a less dense medium to a more dense medium, we know it bends towards the normal, not away. So D is the correct one. C is out. All right. 20. Which statement is correct? Total internal reflection only occurs when light travels from air to glass. Wrong. Right. You guys also just wrote this in your P2. One of the conditions for total internal reflection is that light must be traveling from more dense to less dense, not the other way around. The larger the refractive index of glass, the larger is the critical angle. This is wrong, because the equation is this. If n goes up, then sine c and hence c would go down. So there's sort of like an inverse relationship. When total internal reflection occurs, the angle of incidence is equal to the angle of reflection. This is true, because at the end of the day it is still reflection, and this is wrong. Right? When the total internal reflection occurs, the angle of incidence has to be more than the critical angle. This is also what you've written in your structured questions. Alright, 21. An object is placed in front of a converging lens of focal length 4 centimeters. Height of the image is 6 centimeters. Arrangement is shown on the scale diagram. So this is not a drawn to scale diagram. This is scaled. So the focal length is 4 centimeters. If I look here, this is the center of the lens. So 1 and 2, these are basically 4 centimeters. So I get this sort of a scale from here, that each large box, 5 small boxes, is 2 centimeters, right? What is the linear magnification? So I can see the height of the image is 6. That's what is given to me. So 1, 2, 3, exactly 3 times 2 is 6. So magnification, if you remember, is image height over object height. So 6 over this thing. So this is 1 and 1.5. And 1.5 times 2 would make this 3. So it's 6 over 3. If you did not pay any attention to this at all, you could have still gotten the magnification. If you just look at the number of boxes, so this is 5, 5, and 5. So that would be 15, and then 7 and 5 and 2.5. So if you also did 15 over 7.5, in that case as well, you would get the answers too. Right? So magnification is image height over object height. 22. Which range of sound frequencies include only frequencies of sound that can be heard by a healthy human ear? So only frequencies of a sound that can be heard by a healthy human ear. So we know it's 20 to 20,000 hertz. So we're looking for a range within this range. 0.5 to 50 is not acceptable because 0.5 is less than 20. 5 is similarly not acceptable. 50 to 5,000 is very much acceptable because that lies within this range. And again, up till 50,000 is greater than the 20,000. So this is also not acceptable. 23, again a question of old. An aircraft flying through the air becomes electrically charged. What causes this to happen? So it's basically charging by friction, charging by rubbing. So it's friction of the aircraft with the air. 24. Two metal spheres are brought close to one another. The two spheres repel. What statement explains this? Obviously, if they're repelling, they must have like charges. So both must be charged and both are positive. True. Both are charged. One is positive, the other is negative. They would have to then attract. Having the same number of electrons or protons is not going to determine how they behave with each other. 25. A student sets up a circuit as shown. The lamp does not light. What makes the lamp light? So this is the positive end. This is the negative end. We know that for the diode to basically be in forward bias, the current must flow in exactly the same direction as indicated by the diode. So either you switch around the power supply or you reverse the diode, right? So what do? Changing the supply doesn't make a difference, Reversing the battery connections, reversing the connections to the lamp does not make any difference at all, right? The lamp does not depend on direction, the diode does. 26. Circuits P and Q each contain two identical resistors, each of resistance R. what is the resistance of P and the resistance of Q. Again, you have two identical resistors in series, so the resistance is going to be 2R, and because you have two in parallel, the idea is it's going to be R by 2, right? Because as many identical resistors you have in parallel, the resistance is divided by the number of resistors. If I had 4 resistors in parallel, that would be R by 4. Current in a electric motor is 2 amperes. It transfers 20 joules of energy in 5 seconds. What is the potential difference? Potential difference is W over Q. So here, if I look at this, so W or energy, work or energy is the same thing. So that's 20. And I need Q here. But I have current and time, so I can calculate Q. So it's going to be IT, so 5 times 2, which is 10. So 20 over 10 is going to be 2. Another way that some of you might be thinking of, and that's also perfectly fine, is if you use P equals to VI, right? Energy over time, 20 over 5 is going to be your power, and this is I, and you can also find out V, and that would also give you the same answer. 28. 3 students make comments about appliances with double insulation. Appliances with double insulation do not need an earth wire. Correct. Right? Appliances which do have double insulation do not need an earth wire. So any statement which does not include P is wrong. P has to be correct. So basically D is wrong. Q, double insulation protects the user of the appliance from an electric shock. True. Right? That's what double insulation is used for. Circuits of appliances with double insulation do not contain fuses. False. Fuses are still used in appliances with double insulation because fuse can basically protect the appliance, and even if you have double insulation, the appliance can still get damaged, so we still use fuses. So it's P and Q only, so option B. 29. A magnet moves at constant speed through the coil of wire. The coil is connected to an oscilloscope. The diagram shows the trace produced on the screen. The experiment is changed and a new trace is produced. So the magnet was moved through the coil of wire. So previously it was a negative EMF and then a positive EMF and then a horizontal line. Now you have a positive EMF first and then much of a horizontal line, so no EMF then, and then a negative EMF, and then again zero EMF. Which statement explains why the new trace is different from the original trace? So the first thing we can see is that the polarities is changed, right? Previously we had negative first and then positive, now we have positive first, then negative. So according to Lenz's law, this must mean that now we are making some changes as to how this EMF is produced. If you look at the options, so it must be the case that the other pole of the magnet is now entering first. If the same pole of the magnet was entering, the polarity would be the same, right? It would be first negative and then positive. And then for the length of the coil, the idea is this, that when it's passing through the middle of the coil, so remember, I also made you guys draw this diagram, then no field lines are cut through the middle of the coil, right? When it's exactly in the middle, no field lines are cut. In this one, there's a negative and there's a really fast transition to the positive one. So this coil must be short for there to be no region of zero EMF. But if the coil is longer and as the magnet is falling through, when it's in the middle, no EMF would be produced because it's cutting field lines the coil is cutting field lines at an equal rate from the top and the bottom. So it must now be longer. So it's A. Also, this question is also repeated. It's not new. 30. A bar magnet is dropped through a vertical solenoid that is connected to a sensitive ammeter. Current is induced in the solenoid and the solenoid becomes an electromagnet. Which row describes the polarity of end Y of the solenoid and the force between the solenoid and the bar magnet when the bar magnet leaves the solenoid? So first we are talking about end Y, right? Which row describes the polarity of end Y of the solenoid when the bar magnet leaves the solenoid, right? So this is basically there should be like probably like this, right? So both of these cases are asking for when the bar magnet leaves the solenoid. So by Lenz's law, if it is going to leave the solenoid, this when it's going to be leaving, the south pole would be at the bottom and it's going to stop it from leaving according to Lenz's law. So Y must be a north pole to attract and to stop it leaving. So it's going to be A or B, right? And then for the next one, the force between solenoid and magnet, again, to stop it from leaving, it has to be attractive. Which graph shows the voltage output against time for a simple AC generator? So we know it's what we call a sinusoidal shape, obviously C, right? Also not a new question. Also another older question. Charger for a mobile phone uses a transformer which steps the voltage down from 230 to 5. Primary coil has 2500 turns. How many turns on the secondary? So we just use the transformer equation. So NP over NS equals VP over VS. So NP is 2500. NS is what I have to find. VP is 230. VS is 5. So basically making NS the subject. So 2500 times 5 divided by 230 is what your answer would be. And it should be this. I'm guessing it won't be exact and you would have to round off. A commutator is connected to the coil of a DC motor. The commutator rotates and connects the coil to the power supply. Once every half turn, the current in the coil reverses. We know this. What is the name of the commutator and what is the orientation of the plane of the coil as the current reverses? So I know that the current reverses basically when both of these, if you see, so when the commutator is not in contact with either of the brushes, right? So just as it turns, so that's when it's vertical. So if you look at the field lines like this, so that is when it is, so orientation of the plane of the coil, right? So how is the plane of the coil here? So the plane of the coil is parallel to the field, perpendicular to the field. So plane of the coil is perpendicular to the field. And what's the name? So the name of these is split ring. How can you memorize this? Is because in this case the ring is actually split. It's in two parts. In slip rings, in AC generator, it's the entire ring. It's one full piece. But here it's broken, right? So the ring is split. A girl makes a simple transformer to illuminate a low voltage lamp. Transformer is shown. What is the material of the rod? What is the type of power supply? We know that for a transformer we need to have AC and the material of the rod must be iron, right, to enhance that magnetic field. 35. Which particles are in the nucleus of a large atom? Again, we know nucleus contains only nucleons, so protons and neutrons. C, easy. Alpha beta are emitted during radioactive decay. What particle has the weaker ionizing effect? That's beta. And weaker penetrating power. So weaker penetrating power is alpha. C. 37. A beam of beta particles passes into a magnetic field and into an electric field. Which number shows the path of the beam through the field. So we basically have to identify what the beta particles are, right? So if I look at the electric field first, because that's easier, beta particles are negatively charged. They're really electrons traveling at high speeds. So it must be going towards the positive plate. So it has to be 6. So either B or D. And then for this one, you can also choose to use the left hand rule, but the examiner has made the diagram so that you don't have to do this. If you look at this, 2 is obviously gamma. 2 and 5 are really gamma because they're undeviated in both fields. If you look at 1, it goes like this. But if you look at 3, the way 3 is drawn, this shows a sharper deflection, which you know is what we expect of beta, right? This is what we expect of beta, because beta is lighter, so it has a greater deflection, so it has to be D. Again, if you don't trust me, or if you don't trust yourself, you can also still try to do this using the Fleming's left hand rule. Again, because this is beta, so if it's traveling like this, because this is a negatively charged particle, the direction of conventional current would be opposite. Field lines would be north to south, and it's being deflected downwards, so it makes sense that it's 3, right? So it's being deflected downwards, so it's 3. 38, isotope radon has a half-life of 3.8 days. Which statement about a sample containing 1 mg of radon 222 is correct? After 1.9 days, there is 0.5 milligrams of radon left. Wrong, right? After 1 half-life, it halves. So after 3.8 days, there would be half of that, which is 0.5. That would be left. After 3.8, 0.5 is left. So this is true, obviously, right? Because after 1 half-life, the mass of the sample halves. Its half-life is half of that of a 2 mg sample. Not true. Half-life always remains the same. There is no radon 222 left after 7.6 days. Again, not true, because according to the theory of radioactive decay, no radioactive sample just completely finishes. 7.6 days is 2 half-lives, so it halves and then halves again. So it would be a quarter of what it was initially. What is the first stage in the life cycle of stars? So it's the cloud of gas and dust, which collapses to give you the protostar, right? So that's this then. 40, what is the definition of redshift? A says increase in observed frequency. This is wrong. You know it's the increase in observed wavelength, or you can say the decrease in observed frequency, right? And light emitted by distant galaxies, that is blue when it reaches the Earth, again doesn't make sense. Light reaching the Earth, that is red when it is emitted, doesn't make sense. We say that because of redshift, light appears redder. It's more red, it's shifted towards the red end of the spectrum than it actually is.